All right, question 21a here. So we're gonna sketch the graphs of y equals 1 over f of x, given that this is our function here. And then we're going to state the equation of the vertical asymptotes and the y-intercept. Okay, so the very first thing that we're going to do here is identify, okay, that the x-intercept here on the original becomes a vertical asymptote here, okay? So in this case, because it looks like we're going through x equals -1, there's our vertical asymptote, x equals -1, okay? Now, this also becomes a gap in our domain, okay? So our domain here would be that x cannot equal -1, okay? It's the set of values, x can't equal -1. Now, the next thing that we're going to do here is identify, I'm going to draw a line across here at y equals 1 and y equals -1. And once again, the reason why I'm doing that is because this splits the top half into two regions. All the points from above that line are going to drop below this line. Okay, so they're going to move from here to here. All the points below this line are going to drop in between those two. Like they're going to swap, okay? Remember, these points here are going to swap locations with those points. These points here are going to swap locations with those points, okay? Now, I can identify at that point the invariant points wherever my graph crosses the line y equals 1 or it crosses the line y equals 1. Those are my invariant points. They're not going to change. So these 2 points right here are going to be on the reciprocal. They're not only on the original graph, but they're on the reciprocal. And now it's a matter of just obeying the little rules here. Now, so from here, if we look at our invariant point right here, and then just look what happens to the original graph as you go to the left. The original graph drops down to infinity. Okay, so as you move along the graph to the left, it goes down. So our reciprocal is going to be, if the original graph gets further from the x-axis, the reciprocal is going to get closer to the x-axis. Then I stop and consider, well, what happens if I go from this invariant point the other way? Well, in this case, the original function gets closer to the x-axis, so our reciprocal is going to get further away. Now, remember that this is a vertical motion here. This point jumps up to this point. This point jumps up to this point. It doesn't go sideways. It's just a vertical motion here. Then we move across the asymptote to this point right here, the invariant point. To the left, okay, if I start at the invariant point and go to the left, the graph gets closer to the x-axis, so my reciprocal is going to get further away from the x-axis. To the right of the invariant point, the original function moves away from the x-axis, so my reciprocal is going to get closer to the x-axis. So that's what the graph is going to look like. And now what I got to do is identify the y-intercept. Well, the y-intercept in this case on the original graph was 1. Because that was an invariant point, I can see here that the y-intercept of my reciprocal is also going to be 1.